So good morning everybody, myself Acharya Vishvendra, and today I'm here with a JEE advanced question on elasticity. So there is a frustum given to you and a mass is attached to the frustum as shown in the figure. The top and lower radii are r and 3r respectively, and we need to find change in length of the frustum due to the weight. So here the concept is that we know that elemental change in length is FL upon AY, but here the difference is that area of cross section is different at different points. So the concept behind solving this question is we take at a position x an elemental length dx because its area can be assumed to be uniform pi r square. So we find the elemental change in length of this small part, and then we are going to integrate the entire expression to get net change in length. So let's begin with things. So here is mgl upon ay, as the entire mass will be the force acting on this. We assume that frustum is massless. So from here we get the elemental change in length as mg into dx upon pi r square into y. So we can make this triangle, and from the triangle we can say that tan theta is equals to 2r by l, which is also equals to r minus r upon l minus x. So using this expression we get r small r as a function of x, just like this. So we just substitute the value of the small r. So here the expression comes out to be d delta L is equal to mg dx upon this thing. So d delta L comes out to be this. So delta L will be the integration of this. So integration of this thing. So when we integrate, take this thing as common, as integration of dx by 3l minus 2x all square. So this has got the standard integration as shown in here. Limit is from 0 to L. Limit of x is from 0 to L. So we just substitute the limits, and after the calculations involved, finally we get mgl upon 3 pi y into r square. So you have seen that even in JEE Advanced, the topics or the questions which are asked are based on a fundamental concept. So if you are clear with the fundamental concept, there is certain manipulation involved. It may be involving integration, it may be involving multi-step processing, but ultimately if you are comfortable with all the dimensions, you have practiced enough, then you can make up the question. So this question is basically from the chapter elasticity, and that too it's from finding the change in length of a rod when a certain external force is applied on it. So the basic concept here is that suppose there is a rod of length L and you apply a force on it like this. So the change in length is FL upon AY. So that this question has been solved using this concept. So if you are thorough with the concepts, thorough with the questions, then at least you are comfortable in working on the very few steps, and rest of all is the game of your patience, your calculations, and the capacity to decode the pattern given in that particular question. So this was a question. Thank you and have a nice day.